days, we pick up given percentages, right? If we go up 16 to here, that'll give us what, 282? I think I did that right.
Yeah.
And if we go down 16, pretend those are symmetric. See how the lines put it off there. Don't pretend that's even. Yeah, 250. So there's 2/3 of your births right there. There's 2/3 of your births. Right? If you want to bump it to 95%, you bump it up to here and down to here. That's 16 more. So now we're up to what, 292. Although I hope poor mothers don't have to do that. Or down to here, right? 234. Fair enough? So, where are the preemie births? Where are the preemie births? Who's feeling brave and wants to draw a little line? Now, I don't want exact. I want relative as to where the preemie births are. Relative, not exact. We'll find the exact day in a second via calculations. But where is it going to be-ish on that curve? If it's got to be the 5th percentile. Check, don't break. Sure. Yeah, you are. Go for it, brother. Love it. Uh-huh. 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 Love it, brother. Love it. How'd you know that Trevor explained? That was perfect.
Well, the
What's that?
234, it's about 2%.
That's about your 2.5 percentile, isn't it? Remember why? Let's go back. I love this. I love what you're saying because it brings us back to the old time. Yes, this is 95% of the data. That means these two tails are 5% total, which means 2.5 is here and 2.5 is here. So this is 2.5 percentile. What percentile is that one? What percentile is that one? This is a compound question. What percent is here? Let's start with this. What percentage is here between these two? Go ahead, be brave. 68, right? There's your 2/3-ish. So 68%, which means the other 32% is here and here. So cut that in half, that's 16%. So that's your 16th percentile. There's your 2.5 percentile. So clearly the 5 is closer to the 2.5 than the 16. But our job is to console the mother that's freaking out right now because we just mentioned that there's a chance she's going to fall into the preemie births. So our job is to get off of this curve and back into a curve that we can actually generate a score from. Backwards problems don't start here, they end here. Does that make sense? Because you eventually have to get a number that Trevor drew in for us perfectly. We have to find that number. But that number has to start over here. We've got to start on this stub-normal curve, which zeroes out in the middle at 0 and has a plus or minus of -1, +1. So if you think about it, -1, +1, these correspond to these guys on this curve, don't they? Right? They're the same correspondence. So -2's here, +2's here. Those guys correspond to these guys. So it's clear to me, and from Trevor's drawing, that the z-score we need is going to fall somewhere right about here. It's somewhere between 1 and 2, isn't it? Based on where he drew it, and he drew it correctly. It's got to be outside of 1, but inside of 2. Our job? Find it. Well, we can do that. Because we know what area did I just shade right there. What did I just shade? Go ahead. I shaded the 5th percentile, so I just shaded 5%. Can we find the z-score that chops 5%? Say hell yeah. There we go. That was a little better than last time. Let's find the z-score that shades 5%. Yes. So yes, we come back in here. Yes. Very nice. Fire it up. We're done with that. More problems, more probabilities? Yes. It's still a backwards problem. Which way you want to shade? Your choice. Left or right? Left makes sense because that's what I drew. I drew 5% left. If you chose to shade right, what would you put in? 95% because it shades the same. It gets the same z-score. Let's go left. That's the most logical. 0.05. Make sure to put the 0 in there. That's an easy mistake to make if you're working quickly. Here it comes. Looks damn close to what Trevor drew. There's your z-score. -1.64. Makes me happy. Makes me happy because it's between 1 and 2 standard deviations. Why is it negative? Why is it negative? Because it's left of average. It's shorter than average. Positive 1.64 would be the 95th percentile. That would be the longest that would be in the top longest 5% of first, not shortest 5, longest 5%. Good. Back over here. That's all we needed the normal for, friends. I mean, believe it or not, that's all we needed it for, was to generate this value right here, negative 1.64. Once you have that, all we've got to do is convert that. Now, you don't tell the mother that. We have to have a z-score of no less than negative 1.64. Because we got to punch you in the face, as you should. What you have to do is, that doesn't tell us anything, because what does that not have? There's no unit on it. I need to know the number of days. So how do we convert negative 1.64 to something meaningful?
So, 266
Mm-hmm.
plus 15 multiplied by that.
We have to take the average and figure out what 1.64 standard deviations below that is, below being because of the negative. So we're essentially, if you will, we're using this again, but you guys are doing it intuitively, which I love. You're not actually saying use the formula, although you are. You have to figure out what right there. You're starting at average, which is 266 days. And then you're subtracting off 1.64 of those standard deviations, which are 16 days. So one of them, if you subtract off one, you'd be down to 250, as we figured out already. Then you have to subtract off roughly 2/3 more, which would be like 10, I guess, ish. So you're going to lose about 26 days. What do you want to call that? 240-ish? What are you guys getting as far as the calculation?
239.76.
Let's call it 240, shall we? 240 days. That's the cutoff, friends. That's the cutoff. If your pregnancy is any shorter than 240 days, you're in that bottom 5% of pregnancy lengths. And that, by this definition anyway, is what a preemie birth is called. By that definition, right? That might not be universal. I actually got into a near fist fight with a midwife in one of my 243 classes once. This is not even classified premature. Okay, it's cool. And she was pissed. I'm like, I don't want to piss you off. I'm just saying, this is what I pulled out of a journal. Well, that journal's not. Okay. Okay. You can kick my ass, but I don't want you to. I don't need to see that. So, but the point is, based on that data and that definition, that is the cutoff. That's the cutoff. Fair enough? Yeah? Ish? Good. So look at the pattern for a backwards problem, and you'll see after break how we're going to do a forwards problem. We're going to reverse it backwards. Backwards starts with the normal, gets a z-score, and then changes the z-score into what we'll call an x-score. So there's the good. There's the pattern. The normal curve to z-score to x-score. So a forwards problem is going to go exactly the opposite. Start with an x, go to a z, go to a normal curve. We'll come back to that after break. Take 5. And then we'll roll some dice.